Hi class. Here we are going to continue in section 4.6. So this is the second part about solving exponential equations. So there's quite a lot of equations here, and as usual, just to make it easier for you, I'm going to break up the video into a few smaller pieces. Okay, so we see that we are trying to solve the given exponential equation, and we're going to give the exact answer and the approximate answer to 2 decimal places. So I want you to be able to tell the difference between the exact answer and the approximate answer, and we'll discuss that as we go through the examples. So in the first example, we see the equation 5 to the negative x power equals 25. So in the past, we would have solved this by writing 25 as 5 squared and using the fact that these both have the same base, we can directly say that minus x equals 2. That is using the fact that the exponential function is 1 to 1. So we would solve by saying that x equals 2, okay? So this is perfectly fine. This is like the old way of doing things, but I also want to point out that we can solve all the exponential equations in the same way, so it's not as confusing to think that there's different ways to do it. If you want, you can solve them all using the logarithm, okay? So we can just see that we have the equation that we start with, 5 to the minus x is equal to 25. And to get rid of, see, x is in the exponent here. So we need to get x down from the exponent. So when x is stuck up in the exponent, you have to take the log to both sides. So we would do the log, and we can do any base. It doesn't matter, but I will do the base of 5 just to make the cancellation the easiest. Okay, so then this will say that the log base 5 of 5 to the minus x equals the log base 5 of 25. And the reason that we do this is because now we applied the function and its inverse, we composed them, so they cancel. Therefore, on the left-hand side, we only have minus x. And on the right-hand side, we have the log base 5 of 25, which we know is the log base 5 of 5 squared. So again, these cancel, and that equals to 2. Okay, so then we again get the same answer. X equals -2. Oh, sorry, it looks like I forgot to write the negative on this one, so good thing we went through it another way. And in this case, just to be clear, -2 is the exact answer and the approximate answer, because if we put it on our calculator, we'll get -2.0, and so there really isn't any approximation required in this case. So to 2 decimal spots, it would just be -2.00. That is actually the exact answer. Okay, so yes, I prefer to use the second method in general just because it will work for a larger class of equations. Take a look at part B. Now we have 3 to the x power equals 14. So what power do I have to raise 3 to get 14? Well, it's not going to be a natural number because the first power of 3 is 3, the second power is 9, and the third power is 27. So I know the answer is some number between 2 and 3, but I don't know what it is. So I can't use the old method of writing both sides as powers of 3. I have to take a logarithm. Okay, so because I have the exponential function of base 3, I will take a log base 3 of both sides. So I have the log base 3 of 3 to the x equals the log base 3 of 14. And now we have cancellation due to the inverse property. So on the left-hand side, we have only x, And so x is equal to the log base 3 of 14. This is the exact answer. Okay, but you can think of it like this. That's the exact answer, but what number is that? We kind of know it should be some number between 2 and 3, but we'd like to have a decimal approximation. So to get the approximate answer, we must enter this on our calculator. Okay, so remember, on the calculator, you do not have a button for log base 3. So you need to use the change of base formula when you have a log whose base is not e or not 10. Okay, so I have to use the change of base formula to put this on my calculator. And I will put everything in terms of the log base e, that is the natural log, because that's my favorite log. Okay, so the log base 3 of 14 is equal, by the change of base formula, to the natural log of 14 over the natural log of 3. Now I can enter this in my calculator. And when I do, I get out the number 2.402 ... So if I'm going to be supposed to round it according to this to 2 decimal places, so then I can say that my approximate answer is 2.40. Okay, which matches what we thought the answer would be. Okay, so if you're watching this video at home, I suggest that you pause for a second and try parts C and D by yourself, and then just come back to the video to check your work. It's very important, as always, in my perspective, that you don't just watch me do the problems, but you have to attempt to solve the problems yourself. Okay, so hopefully you attempted to solve the problems yourself. So for problem 2, because I have 2 to the power minus x, I have to do log base 2 to both sides. So I'm going to take the log base 2 of 2 to the minus x, and whatever I do on one side, I have to do on the other side. This will equal the log base 2 of 1.5. So we did that in order so that the log base 2's will cancel. Now I have minus x equals the log base 2 of 1.5. And so to solve for x, I just divide both sides by minus 1. So x equals negative log base 2 of 1.5. This is the exact answer. And to get the approximate answer, that means I have to put this on my calculator. And again, it's a log base 2, so I need to use the change of base formula. So I will have natural log of 1.5 divided by natural log of 2. In my calculator, I get approximately negative 0.59. This is the approximate solution. Okay, so now we just have part D. If you're following along and you just want to see if you got the right answer, the approximate answer is negative 1.46. Now we'll go through the computation. So this one is only slightly more complicated. And when you take a look at it, you should do the analysis like, here's x that I need to solve for. And basically, solving the equation just means undoing everything that was done sequentially, applying inverse operations. So what we see is that this 0.3 on the outside should be divided before we apply any logarithms. Actually, it would also be fine to apply a logarithm directly and then use the sum property to solve the equation. But for me, I'm just going to divide first. So as with always solving equations, there's numerous ways to do it. And the good thing is that we always come to the right answer as long as we do the right steps. Okay, so first I divided both sides by 0.3. And now I have just an exponential function, so I'm going to apply the inverse of it by taking the log base 4 on both sides. I did that because now I have cancellation on the left. Therefore, I know that 0.2x is equal to the log base 4 of 2/3. And so to solve for x, I just divide both sides by 0.2. So I get x equals the log base 4 of 2/3 divided by 0.2. So this is my exact answer. And when I put it into my calculator, this symbol means is approximately equal to, I get the negative 1.46 as the approximate answer. Okay, so this is some basics on solving exponential equations and on the difference between exact and approximate answers. I'm going to stop this video and then make another video for the next few problems, which are a little bit more complicated.